Well, good day to you all, and welcome to the Institute of Marine Engineering Science and Technology, and thank you very much for joining us. Apologies for the slight delay in starting this morning, only slightly ironic that we've had a few IT issues. I don't think it's been a cyber attack. I'm Captain Matt Bolton, and as chair of the newly formed Naval Engineering Special Interest Group, it's my great privilege for me to introduce our first webinar on the subject of cyber and the digital Navy. How well are we prepared for the digital age? How safe and secure are our systems? And are we ready for autonomy? To help us answer some of these questions, I'm delighted to introduce our speaker, Mr Bernard Twomey, who will explore the cyber threat, consider the human element, and discuss the regulatory landscape. Following a 4-year apprenticeship, Bernard served at sea in the Merchant Navy for 12 years. Graduating from Loughborough University with an honours degree in electromechanical power engineering, he is now a visiting professor at the University of Strathclyde. He also holds a PhD research post in the Department of Computer Science at the University of York, where he is researching maritime autonomy, and where he's also a member of Lloyd's Register's Foundation's Assuring Autonomy International Programme. Joining Lloyd's Register in 1993, he became the global head of electrotechnical systems until he left in 2016. In 2017, Bernard joined Rolls-Royce Marine, responsible for the regulatory development activities surrounding maritime autonomous infrastructure. This role continues with the sale of Rolls-Royce Commercial Marine to Kongsberg. An active member of several research and special interest groups, Bernard sits on the technical committees of 2 leading classification societies and is also a member of BSI and CMAC. He is an advisor to the Danish Maritime Association at the IMO, has been a review panel member for the UK's Type 45 destroyer, Queen Elizabeth class aircraft carrier and Astute-class nuclear submarine programmes, and is a member of the advisory panel developing the NATO Allied Naval Engineering Publication 77, the Naval Ship Code. Bernard, if I could please invite you to the lectern.
Great. Well, thank you very much for that. Thank you very much for that kind introduction. The question that you actually posed me was to look at the cyber and the digital navy This is an extremely challenging subject, basically because, we'll come on to a number of reasons why, but this is an extremely challenging topic. Firstly, because it is a real threat to the industry itself and the sector. But I think the way to actually address this, I've got a series of slides which hopefully you'll find interesting, and I'll try and give you an answer to the exam questions which you actually posed. So during this presentation we'll have a look at things like the definitions, vitally important. One of the key things we find in at the moment whenever we have a discussion is that whenever you talk about a certain subsystem or even the definition of a system, many people have different definitions of what that actually means. We'll look at the journey towards autonomy, what the maritime vision is, whether it's a real vision, whether it can actually be realized, a bit about the autonomous infrastructure, the challenges to enable that infrastructure to take place, look at key enablers, security and safety, vitally important, and then we'll look at some key takeaways. So the question that you posed me was basically, how well are we prepared for the digital age? Are we ready for autonomy? And how safe and secure are our systems? So let's take each of these in turn. First of all, I'd like us to have a look at the technology which is now being used within the maritime sector to deliver a maritime autonomous infrastructure in various formats. I'm sure everybody's actually seen the videos that have actually been put out there. The top left-hand one, these are all courtesy of Rolls-Royce, by the way, and the Yara project. So the top left-hand one is a vision of a fully autonomous cargo ship from Rolls-Royce. The one on the right-hand side, top right, is actually a fleet of vessels operating from a remote control center. So therefore what we're doing in that effect is we're reducing the resource on board the actual vessel itself. The one on the bottom left-hand side, again, an excellent video from Rolls-Royce, but then actually shows an operator and a remote operating control center actually controlling multiple vessels, which could be the ones on the top right-hand side itself. Now what I can tell you is that Rolls-Royce were aiming towards delivering this capability, and that is now continuing into the likes of a number of manufacturers to try and deliver the capability which is now being pushed forward by the industry sector itself. The one on the bottom right hand side is an interesting project. That's the Yara project. This is a cargo vessel which is going to operate solely within coastal waters of Norway. Again, it's going to operate fully autonomously in time. I think initially it's going to operate from a remote control center. So the question here is this technology, so the technology is readily available. There are advances in technology to ensure that the integrity of the system is actually increased. But the challenge here is that the real issue? We'll come on to that a little bit later. But that's a significant change from the current methodology of putting vessels in the water to the ones that were actually going to be required to implement a fully autonomous infrastructure that will get agreement from the regulatory authorities. So what are these systems? Well, these systems are basically, if we have a look at some of the definitions first. So the IMO defined the maritime autonomous surface ship as a ship which to varying degrees can operate independently of human interaction. And they looked at a degree 4 fully autonomous ship is defined as the operating system of a ship is able to make decisions and determine actions by itself. In contrast, we have the US Defense Science Board, DSB Task Force. They define autonomy as a capability or a set of capabilities that enable a particular action of a system to be automatic or within programmed boundaries and basically being self-governing. The Royal Academy of Engineering put a slightly different perspective on it when they turned around and said that the autonomous systems make information decisions for themselves in complex environments. The system can have a physical manifestation, such as a vehicle or a robot, purely software-based, such as a financial trading algorithm or a medical decision support system. And what they did in effect, they categorized that as 4 different levels, look at impact. Now the interesting thing here is that both the Royal Academy and go back a minute, and the US Defense Board actually looked at things, talked about capability and impact, whereas the IMO didn't. And I think from a military perspective, I think the definitions which are given by the Defense Board and those from the Royal Academy would probably be more suitable to a naval application than those currently being specified by the International Maritime Organization. To get these platforms into the water itself, one of the most important things that we need to understand is that these are not just technical issues. The technical part of it, I think, can be put into place by a lot of manufacturers. The issue here that this is a socio-technical systems, where we have a system which, by the way, is a set of elements which interact according to design. And the diagram on the right just gives you some idea of the level of complexity that we're actually dealing with. One of the most important aspects here is the interaction between the people and technology as a defined factor in the overall system design. If you fail to consider the human as part of the system, then the chances are that the outcome itself is highly unlikely that that's going to be achieved. So the human forms very much a part of the system, or the socio-technical system itself. And we come to a major, there we go, right. So what does a maritime autonomous infrastructure look like? Now, people will talk to you about the autonomous ship. And that's okay for a level 4 system. because a level 4 system is, as defined by the IMO, is a fully autonomous vessel itself, can look after itself. But what we have here is, in terms of the infrastructure, if we're going to look at a remotely controlled type vessel, we're going to look at things like Fleet Operations Center, Shore Control Centers, the Remote and Autonomous Ship as a subsystem, the Simulation Center and Intelligent Analytics Center. And I think the key takeaway here is, certainly in the commercial world, is that the ship is actually connected and connected at all times. In the naval environment, there are certain evolutions of the platform vessel itself where you may want to disconnect the outside resource from the actual vessel itself, maybe for strategic reasons. But if that is the case, then the analytics, which are normally carried out by the intelligent analytics system itself, or even some of the analytics which are carried out by the remote operator, are now going to have to be put back on board the platform itself and the vessel. If that is the case, how have we got the skills necessary for the future residing on board the actual platform itself, vessel? And this is a question I think needs to be raised. It's okay, the technology, all these are actually in place, and there's been some very successful projects out there at the moment demonstrating that this can actually operate successfully. But in a naval environment, if we have to disconnect, then what does that actually mean for the people on board the vessel? If we look at some of the features from the technology itself, from a commercial environment, we're looking at removing the hotel systems, carry more cargo, we're not going to have any deck houses, there can be lower power demands. Interestingly enough, if we're looking at redundant machinery, what does that actually mean? And then we look at increased automation and sensors. So we're actually increasing the complexity of the actual vessel itself. But I want to ask a few questions. What type of fuel are we going to burn within these platforms? What do we do about redundancy? How do you survey? How do you maintain? How do you look at, there's no LSA, life-saving appliances on board. The safety assurance case has to be maintained throughout the life of the asset. And one of the important things for me is, how do you actually set this thing to work if I've got no services required for habitability? I think these are questions which I think need to be answered. So it's not only looking at the benefits, it's actually looking at the challenges for putting this technology in the water itself. In terms of reliability, so this was a goal that was actually put to me by a client to basically turn around and say, no single point event shall result in a key hazard taking place. That key hazard, by the way, was fire and flood within an engine room space. So the question here, could you have a single engine room, single shaft line configuration? If you look at the hazard and risk analysis, the answer is no. So how do you actually meet those particular goals? And one of the important things here is you need to have an understanding of the goals before you can actually start looking at the design of the actual asset itself. So as a starting point, I think one of the most important things here is if we are going to have off-ship capability installed on your platform ship. If the answer is yes, my question would be, what is its function? And there's a list up there. Is it for monitoring and optimization? Can I alter parameters? Can I put software patches in? Can I upgrade the software remotely? Can I actually control the subsystem from ashore? If the answer to any of these questions is yes, then it really needs to understand. We need to understand, it's got to be documented. The people on board the vessel itself need to have a clear understanding that if somebody else is making these changes on board, how do you do the validation and verification? What am I left with? Especially in a naval platform, because we talked about disconnecting from the outside world. And if that is the case, then the people on board the vessel need to have the confidence to understand what they're actually operating and controlling. Just to give you an example that you may turn around and say, is this technology already available? Just a quick couple of slides to show you. Wärtsilä already have it. And by the way, they've had this for years. What I'm showing you in the next couple of slides is not unique. This technology has been around for a long, long time. So Wärtsilä have the remote monitoring and the systems, they call the RMS. Kongsberg, they have remote services. There they can actually connect to the vessel itself for remote support and configuration. ABB, Integrated Operations Centers, very, very successful. And what we're actually showing here is all readily available. We have Rolls-Royce, and as Rolls-Royce in March 2017, they were going to open the remote controlled and autonomous ship centre in Finland, and that progressed significantly before the sale. So that gives you an idea of the technologies which are already out there and already being implemented and applied. The question is that do people really understand what this actually means in terms of a risk? So let's have a little look at the challenges. So this is a list of some of the challenges. In terms of technology, I told you the technology is progressing. A lot of it is already available. In terms of the legal framework, it's a bit of a minefield at the moment. I'll give you an example. If I work ashore, I'm actually covered by the Health and Safety at Work Act when I'm working in a remote operating centre. But I can actually be controlling a marine asset or subsystem on board a platform. So in the event of a collision, grounding, loss of life, etc., if I'm controlling it, under what legal framework am I actually operating? Is it a maritime legal framework or is it a land-based one? We'll come on to the IMO a little bit later. There is an issue with insurance. Obviously, that's creating a bit of an issue. I'll come on, there is a slide on the insurance side, so I think I'll leave that for a minute. We've talked about the liability aspects to it in case of a failure. The when is an interesting one. There are projects now being proposed which are going to be fully autonomous, and these are commercial projects. And these projects will be realized in a very short period of time. So the answer is when. The when is quite interesting because for coastal operations it's going to happen a lot quicker than if we try and go to international trade. However, there are projects out there that actually want to get involved with international trade. And that's going to be challenging, certainly from a legal and from the IMO perspective. In terms of jobs, an interesting one. So there's been a big question about what does that mean for me as a seafarer, as an engineer on board a vessel, or even a navigating officer on board a vessel. What does that actually mean? I think the challenge is here is to really understand is the allocation of function between the technology and the human and the defined operating conditions. And once we've done that, then we can actually look at the qualifications that are actually required to operate within this environment. There is a cost implication to this. As I mentioned to you before, it's if we're going to design a system such that a no single point failure will result in a key hazard, is the cost of a vessel going to increase, and is it going to increase throughout its lifetime? One of the important things here is that the safety case or the safety argument has to be maintained throughout the life of the asset. This is an interesting one because in naval applications itself, the safety case and the safety argument is well understood. In the commercial world, I would suggest that it's probably not as well understood as the naval applications. But in terms of naval applications, I say it differs from commercial for a number of reasons. Those reasons are that you will have an evolution in that vessel which is certainly significantly different to that of a commercial operation, and that needs to be understood when we're dealing with the risk analysis itself. So in commercial, it's probably down to cost would be the main driver. In the naval, we can take people out of harm's way, but it has to be sustainable under very challenging environments that we don't see within the commercial world. The question I would ask you is how autonomous is the system itself? We can have a mixture, manual, automated, remote control, semi-autonomous and fully autonomous features. The question here is you need to ask yourself how autonomous is the system or how autonomous do I want it? You have to carry out an assessment, but within that assessment, again, I'll reiterate, is the human interaction and human intervention. There's a number of questions, key questions, which are raised there, and you can read them yourself. What is the role of the human in the loop is what I would actually say is vitally important. This is not a static case, because the human may have a completely different function and the different evolutions of the vessel itself, and the defined use cases. What happens in a fail-safe situation? What's the definition of fail-safe? So in the commercial world, you could say fail to the least hazardous state. And you would accept that and you could probably define it. The problem within the naval environment is the bottom one, which does make me smile sometimes, is how do we deal with battle overrides? The question here is, if you now go into, and the technology is actually going to drive you into what that considers to be a fail-safe situation, you may want to have the capability to override that to actually meet your what function you actually want to achieve. And all this has to be taken into consideration when you do the upfront risk analysis itself. There are a number of questions if we are going to put this technology on board the vessel itself, on the platform. In terms of competencies, do we need to have the same certification and competence required as we do today? Or are we going to move a lot of this off to the shore-based staff? And if we are, what competencies do they require? For personnel on board the vessel itself, are they now going to be engineers or operators? That is a significant difference to what's happening currently. Are you going to operate or just maintain? Active or passive monitoring, what does that actually mean? There's a number of questions here that has to be answered before we can actually start looking at the competency and training requirements. Within the commercial world, we've actually turned on and said that maybe we could take STCW and then put a layer on top then to deal with technology, leading towards autonomy. I would disagree with that. I think what needs to happen is you need to understand what the allocation of function is between the technology and the human. Then you need to define what the tasks actually are. And once you define those tasks, then you can actually define the training requirements. And we may be bringing people into our sector where they've never stepped foot on a vessel in their life, yet they are controlling a maritime asset. So what type of competencies are actually required for these individuals? I don't know the answer to how will it work in practice. I think that's probably the subject of another one of these presentations, but I still think it's worth as one of the key questions that need to be answered when we start putting this technology on board the vessels themselves. If we are going to look at the technology itself, there are some cultural implications in terms of perception of risk. As we work at sea, if we put cyber-enabled technology on board the vessel itself, what is the culture of working within that technology? Has that actually been assessed? What will my day-to-day responsibilities be if part of that asset is actually controlled either by the technology or by a human ashore? If changes are occurring on board the vessel itself, like a software upgrade, what are the people on board the vessel actually supposed to do? What are they supposed to, how do they ensure that that system, that upgrade, is not going to result in a failure or a key hazard? The last one is, will the perception of personal risk increase? This is an interesting one, because what we're doing at the moment is the perception of personal risk is an interesting topic, because if you don't understand what the technology is actually doing, how can you actually assess the risk? And it goes back to it again. Do I have the necessary competencies on board the vessel and the information require me to assess whether my risk is going to increase or decrease or stay the same? There's some real issues here around the cultural implications, and I think that's something that needs to be taken forward to address the introduction of this technology. The human in the loop. We keep coming back to the human, which is actually vitally important. There is a thing called a moral crumple zone. To put it into context, if the technology itself finds that it cannot cope with the information that's being provided and it transfers control back to the human, you may turn around and say, that's okay if I'm in a deep sea situation. What happens if I'm just about to have a collision and the technology says I can't do it anymore? I'm passing it back to the human. Is that morally responsible? There's a lot of work being done in this area within the automotive sector. But the interesting thing is, Mika Ainsley, I'll just quote, the more automation is added to a system, the more reliable and robust that automation is, the less likely that a human operator overseeing the automation will be aware of critical information and be able to take over manual control when needed. The interesting thing here is that has to be taken into consideration during the design of the actual system itself. So the human in the loop is vitally important, and we need to understand the risks associated with this. The last thing I would want to be in a situation is where I wouldn't be able to take control and prevent a key hazard taking place if the technology decided it couldn't cope with it. Those three pictures up there, which are actually courtesy of Rolls-Royce again, and the one on the right hand side, just to let you know, is actually the remote operating centre that was put forward for a very successful programme that actually took place in Danish waters. So that's a remote operating control centre. Person in the chair is the master of the vessel, and he's actually controlling the tug in the harbour itself. So that this technology does actually work. What I would tell you is that the current programme was that the master on the vessel is always in command. The control could either be from the shore-based system, the technology on board, or the master on the vessel itself. So that was the fallback position. The master on the vessel is always in command. Let's take a little look about some of the challenges that we're actually facing at the moment. So this is the United Nations Conventional Law of the Sea, UNCLOS. The reason why this has been flagged up is for a number of reasons. What we have here in graphical form, we have the maritime zones. So we have from the left-hand side, we have the coast baseline, and there's where we have sovereignty of that nation state. We have the contiguous zone, the exclusive economic zone, then going back then over the 200-mile limit, we're into the high seas. The projects that we're dealing with at the moment are actually operating within the coastal areas, the territorial seas of that nation state. And therefore, we only have to deal with one legal framework. It's the flag state of the vessel, the area in which it's actually operating. That makes life a little bit simpler. If we now have to extend this into the high seas, and if I do the reverse of that and I want to get to another country, then obviously I have to take into consideration what the illegal requirements are within the territorial seas, and also what the land-based requirements are. So there's an issue here about where these platforms are actually going to operate. They obviously have the right of free passage, that's entrenched in law. But the question is, if I'm coming into a territorial sea, like the UK, or even one of the ports, say Southampton for instance, are there specific requirements in Southampton port? If I'm going to put technology on board, will they allow me to operate that same fully autonomously, or would they require me to operate within that zone under remote control and having a person in charge? The current maritime environment, as the IMO, they highlight the bit in red, is the one I want to emphasise, to encourage and facilitate the general adoption of the highest practicable standards in matters concerning maritime safety. Now that's the articles of the convention of the IMO. This is a list of the highest practical standards for maritime autonomy. There's plenty of guidance documents out there, but there's actually no standards. So the challenge is, what body of evidence do we actually provide to demonstrate that the safety argument is actually being met when there are no prescriptive requirements and no prescriptive standards? And that's one of the challenges that the industry is actually facing at the moment. How do you demonstrate the safety argument has actually been met? To move this forward, the MSC out of the IMO put a series of definitions together, and those definitions are actually quite interesting. This is part of the regulatory scoping exercise that was put forward by the IMO to try and understand and categorise the definitions for autonomy. Whether these stay or not is up for debate. Chances are they're not going to stay, following recent meetings at the International Maritime Organization, but this is ones that the scoping exercise was actually based on. The reason I put these up is we have the definition at the top of a maritime autonomous surface ship. The degree 1 was ships with automated processes and decision support, so we'll have seafarers on board to operate and control. Degree 2, we have remotely controlled ships with seafarers on board. Now the interesting thing here is that you may end up with a degree 2 system where you may look at subsystems which are remotely controlled. Degree 3, we have remotely controlled ships without seafarers on board. And then finally you've got a degree 4, which is fully autonomous ship. What I've just explained here about degree 2, about having control of various subsystems, doesn't actually fall within these 4 categories, because this actually looks at the ship in entirety. What happened at MSc 100 was basically they decided they were going to concentrate on degree 2 and degree 3. Degree 1, where they weren't going to concentrate on, they would leave that for the future, and also fully autonomous ships. A lot of projects actually being put in the water now or being talked about actually fall into the degree 4 category. And for demonstrator purposes, we actually try and put them on degree 1 platforms. So there's a bit of an issue there in terms of the scoping exercise that was actually being put forward by the IMO. If we look at transitions between the various levels itself, the IMO levels 1 to 4, we follow the line on the right hand side. If we change the autonomy level, will it have an impact on the autonomous infrastructure? Well, the answer is yes, because if I have a fully autonomous platform and then I have to transfer control back to a level 3, but I have people on board the vessel, I have remote control with nobody on board the vessel. I now have a shore-based control center, so my infrastructure is going to change, because now I have to look at the legal framework. I'm also looking at legal framework from the land-based side of it. I also have to take into consideration the connectivity aspects to it. So in that particular case, the infrastructure is going to change, and we need to understand that. On the bottom right hand side, the autonomous infrastructure includes the remote operating center or the remote control center, as it's been, but that's considering the human and the technology. If we look at the top left hand side of it, we've got changes in autonomy level will have an impact on the stakeholder community, legal and regulatory framework. And the answer is yes. I'll explain that in a little bit further in the next couple of slides. But if we're going to change the stakeholder community, the legal framework and the regulatory framework, there's significant human element aspects into this. One of the challenges is who are the relevant stakeholders? When do we need to engage with them? And what role and responsibilities do they actually hold? Also the safety case, does that change? Or the assurance case, safety argument, when you transition through the autonomy levels? The answer again is yes, it does actually change. And that's why the safety case, when we transition through various autonomy levels, is actually going to have to be, this is a dynamic model. When we look at the relevant stakeholders, it's maybe a bit small to see, but what I've tried to look at here is try and provide a list, and it's not complete yet. But if we look at the maritime stakeholder community, we're going to look at things like classification societies, regulatory bodies. There's a huge group of other stakeholders, such as the pilotage, even the bunkering, etc. We have the ship owner and we have the insurance market. That's for a conventional vessel. If we look at the ones for the stakeholders for autonomous technology, this is actually quite interesting, because everything in red would be impacted by the introduction of technology leading towards autonomy. On the right hand side, on the bottom, we've actually got a list now of new stakeholders and actors. Those lists of new stakeholders and actors, I'll certainly just highlight one or two, is the land-based legal framework, satellite communication systems, the land-based communication systems. And and that's why this list is vitally important. And the reason it's important is that if you miss one of these actors, stakeholders out of the overall design process, then the chances are that they're going to come up with a set of requirements will prevent that autonomy being placed in the water and allowing you to trade effectively. So the identification of the stakeholder community is vitally important. The future stakeholder relationships is probably more, is going to change significantly to a conventional vessel, because what we're looking at here is a through life safety case. We need to identify the stakeholder community. The humans have to be taken into consideration, and we're also looking at identify stakeholders which are non-marine as I pointed out a little bit earlier, these are organisations who are maybe traditionally not been involved with the maritime sector itself. And the challenge is, if we look at it in terms of how do we assure their activities, that's going to be extremely challenging in the future, especially if they have to comply with the safety case. Let's just say we do all this, right, and we apply to a nation state, and the nation state issues a document as shown on the right hand side there. This is one which was actually put forward to the Maritime and Coast Guard Agency, and what this does in effect is it gives an agreement for that vessel to operate, which may have an exemption against the requirements of SOLAS. They write off to the International Maritime Organization. The International Maritime Organization issues an SLS 14 circular. That would then normally be accepted by all other nation states. It's been fed back to me basically that for the degree of autonomies, or when we introduce technology leading towards autonomy, there is absolutely no guarantee at all that that letter will be accepted by all maritime nation states. And when we start trading within UNCLOS, go from nation state to nation state internationally, we need to understand what the legal requirements and requirements for both nation states with our vessels intended to operate. And that is true, I would think, for all platforms where this technology is actually going to be put in place. And I want to take you through a series of slides just looking at cybersecurity. These are courtesy of Dr. Bob Watts of Rolls-Royce. What we look at here in terms of confidentiality, integrity and availability, this is actually crucial for remote control ships for the future. It's also actually very important for manned ships of the day. And the question here is, our industry is actually, current level of cybersecurity in ships is actually very poor. Everybody's aware of the fact is that land-based entities have actually been attacked within the maritime world itself, and that has had significant financial implications. The view really is that the cybersecurity is not something you want to add on top of the current system. This is something that has to be built in at the design stage. A number of conferences have been talking about cybersecurity, and within marine, there's a perception you can just layer it on top after the system's been designed. A lot of the cyber experts I've talked to, if you want to do that, then you're actually going to fail and you're leaving yourself extremely vulnerable. Let's have a look at the landscape. We've got policy, principles, we've got the standards and guidance documents itself. That is what it should look like, everything linked in together. Actually, that's what it is at the moment. It's slightly fragmented, although I will say it's starting to get a little bit better, especially with the likes of the IACS. IACS have got a working group actually looking at cyber security, and they've got a cyber panel, so hopefully within time we'll be able to get a clear set of requirements that will actually pull the framework together for the maritime sector. The challenge here is, do we make it goal-based or do we make it prescriptive? The problem here is that if we make it prescriptive, the chances are that we're actually going to miss and limit innovation. Likewise with goal-based, the problem with goal-based requirements is basically it's very difficult to cost. Do we treat safety and security as independent entities, or should they actually be merged? I would suggest that you cannot separate safety and security. Certainly not in a maritime environment. And failure to do so could end up in a system which is going to create major problems in the future. Is it sensible, practical and achievable? Or, as Bob points out, rushed anchored to traditional IT models? I would suggest the top one is probably very important. It's got to be sensible, practical and achievable. Noting the fact is we're dealing with an industry where cybersecurity is something which has been, I'm not going to say forced upon us, but we have to be able to manage. In terms of the autonomous vessel itself, we put in technology on board the vessel. That vessel then is taking information from various subsystems. There's a series of checks and balances on board the vessel itself, so we can actually determine that we are protected. But then what we do is we put it into the cloud and we put it to land-based systems itself, and we have two-way communication. The question here is that a level of vulnerability which is tolerable for the maritime sector? The same likewise goes for data and data analytics. We're now sending information ashore, which is going to be analysed by shore-based experts and presented back to the operators on board the vessel, if there are any, and maybe make those changes on board the vessel itself. The question is verification and validation of that data. Is that data correct? And there's lots of attributes of data that preserve safety. The Safety Critical Systems Club have produced a very interesting document to support this, and it's actually called Attributes of Data That Preserve Safety. I would recommend everybody have a look at this. Because if we don't manage this successfully, we could end up in a situation where we could result in an unsafe state. So to manage this, we have the Lifecycle Model, which everybody's seen, the standard V model itself. But to pull the cybersecurity aspects together, we need to look at the links and lifetimes, and they all have to be combined in a single entity. And if we have a look at the chains, there's application layers, vulnerabilities, insecure storage, insider attacks, remote access and patching, which is probably one of the most critical things within the maritime industry itself. I've already showed you a number of manufacturers you can gain remote access into the system, and I will tell you now that this has actually resulted in a near fatality when remote access was actually carried out on a vessel, which actually shut down the ventilation within the engine room space. When they shut down the ventilation in the engine room space, obviously it starved the engine of air, created a vacuum. The ship was at sea at the time, and it was lucky that the chief engineer managed to get out of the space. The interesting thing in that event is that the chief engineer didn't know that capability existed, and the ventilation manufacturer basically said there was nothing in his contract, or nothing in their contract, that would prevent them accessing the vessel. They didn't have to tell the people on board the vessel itself. And the result of that resulted in, I would suggest, a key hazard. In terms of links, there are significant links ship to shore. All these links, if they are broken or you bypass the systems itself, you bypass the bridges themselves, are we then increasing the level of vulnerability? And we need to understand what those links are. Remember, on a remote operating system, we've got the connectivity via the satellite or land-based systems. We can have data analytics. Everything has to be transparent when we work within this environment. And of course, we have the usual things like the USB sticks itself. Should they be banned on naval platforms? I'll leave that up to you to decide. In terms of lifetimes, we've got obsolescence, patching, local access. A lot of incidents that have actually occurred where people have actually accessed the systems locally without following due process. And in one particular case, that shut down the reliquefaction plant and the gas combustion unit on a vessel, LNG vessel. That resulted in that vessel being taken off hire at a significant cost. The actual tanks had gas in, and that was vented into atmosphere, so there was an environmental issue there. But the interesting thing is the local access was the part that actually created the hazard itself. So in terms of the lifetime, it's vitally important. Obsolescence, certainly in the commercial world, obsolescence happens probably a lot quicker than it does in a naval environment, and you have to be able to manage it. The communication of risk is vitally important. As I mentioned before, all the events that I just explained to you could have actually been prevented if the communications had been robust. The problem here is manufacturers are putting technology on board the vessels itself without actually advising the owners and the ship staff what that actually meant. And I think as we progress, as we put more and more technology on board the vessels itself, I think we need to be mindful of the fact that if we don't have a robust process in place, we could end up in some significant issues going forward. The defence in depth is vitally important, but also from the cyber side, you're looking at defence in depth and defence in breadth as well. In terms of operations center security, I'll talk here about physical security. The important thing here is I may have the most robust software-based solution and cybersecurity aspects to it, but in terms of the physical security, is vitally important. And that's something that was missed during one of the projects. And in fact, they had to put security on the doors to prevent people trying to gain access into the remote operating center. So again, it's a risk that if we are putting remote operating center somewhere, don't just look at the cyber aspects to it, you need to look at the physical security of that environment as well. We look at lifetimes, training, vitally important, and recovery. That's something which people sometimes miss. The recovery aspect to it is actually vitally important. If an event takes place, how do we recover? In terms of the industry itself, the malicious or non-malicious cyber event, is there really a difference? According to Norton Rose Fulbright, they reckon that the majority of cyber incidents occur as a result of accidental acts or omissions, which is absolutely fine. But the question here is, a cyber incident can it occur if the OEM is following their own internal procedures? Well, the answer is yes, because I've just explained to you that this actually happened on a number of platforms. And those companies, the OEMs, followed their own internal procedures. So what has the industry done to help support this, or the marine industry done, or the marine insurance industry done to support this? So what they've done, they've got a thing called a cyber attack exclusion clause. And CL380 is a paramount clause included in all marine insurance policies. The clause itself is actually quite interesting. It does actually say, you can read it yourself, but if the event contributed to, by, or arising from the use of operation and means of inflicting harm of any computer system, software program, malicious code, computer virus or process or any other electronic system, if you can prove that it was caused by any of those, then the chances are, if you invoke CL380, it becomes an uninsurable risk. Now the interesting thing here is CL380 is still included. We're now putting technologies on board which may open up greater access into the vessels themselves through the levels of autonomy, but then I have this cyber attack exclusion clause in place. Is that a risk for the industry itself? I'll leave it open for debate, because that is actually being discussed at the moment by the insurance companies. So the challenge is to address cybersecurity. There is a risk posed by the cyber attack. There's a unique combination of properties that need to be considered. If it does happen, it can be severe, as a number of shipping companies have actually found out. If you don't intelligently manage cybersecurity, the likelihood of attack being launched is relatively high. Try and assess it through the lenses of change, links and lifetimes. You need to understand the risks associated with this technology moving forward. So in terms of the key takeaways I would suggest from this is that the maritime autonomous infrastructure extends beyond the physical boundaries of a vessel or platform as been described. You have to understand the risks for every use case. You have to develop a methodology for the assurance and safety case. Don't try and treat cybersecurity as an add-on activity. I think you will fail, and fail dramatically. In terms of the stakeholder community, it's a very dynamic model. You have to develop that model, and you have to consider that model throughout the life of the asset itself, especially if you trade in different areas. Different countries may have different requirements. The assurance safety case is a dynamic process, and that clearly has to be maintained throughout the life of the asset. In a naval environment, I really don't have a problem with that. In the commercial world, just using the word assurance and safety case may create a problem, because it's something which is fairly unique and something new that we're actually putting forward. But without it, how can you actually demonstrate that the safety argument has been met? The education and qualification, the operators, seafarers, need to be based on the use cases, allocation of function between the technology and the human. And I think we shouldn't really underestimate what's actually required here. If we do not take the people on the journey with us, and the industry wants to just develop technology, I think the chances are we're not going to attract the brightest individuals into the environment, which certainly the maritime environment. And for me, that's a significant issue. For naval staff, I think we're going to need new skills to work within the cyber and digital navy. What those skills actually mean is going to be significantly different to the commercial world. Someone said to me that the navies always follow commercial. I would disagree, and I've disagreed with that statement for years. I think there's an opportunity here for the naval environment to actually lead the way, to actually push forward, to identify the skills that are required for the future within their environment. And I think that will flow into the commercial world, rather than looking what the commercial world's going to put forward and then the Navy try and adapt it. I think that's the wrong way. I honestly do. And there I'm going to finish. Matt, over to you.
Thank you very much, Bernard. Please come and join me at the table. The intent now is to open the web to questions, and our assistant here, Maria, I think is going to help us with the process. Bernard, I'm extremely grateful to you for your presentation. It perhaps poses as many questions as it provides us with answers, and I certainly have a sense that this is a topic that we will need to continue to deal with over the next months and years to really address the issues, but of course exploit the opportunities that are presented to us through the digital age. So Maria, questions please.
We have a lot of questions. I'm not sure if we will be able to take them all, but in that case, if we run out of time, I will send them to you and you will provide your feedback. I will start with a very short one that says how we can define cyber-enabled technology.
Bernard, do you want to say that first?
Yeah, sure. It's a really interesting question, because the way it's been dealt with within the International Maritime Organization, they've tried to categorize into the capabilities. Let me just find the slide a minute, which may make it easier to address. It's in the definition section. You know. Here we go. So the International Maritime Organization put together a series of, I think it's on the definition slides if you want to have a look at it. It's right at the top. To go in, next and that, and that. That one.
Yeah.
That one. Right. So in terms of the, just flick it through please. Right. Okay. So what they've done in effect is they've turned around and give these clear definitions. What the IMO, the US DSB is actually talking about a capability. So if you turn around and say that capability is actually going to be used within a software-based solution. So that capability, I make a conscious decision to turn around and say, I want to implement that technology within a software-based solution, then the question here is, would that form the basis of a cyber-enabled platform? If you go to the next one, please, just slide down. Right. What the Royal Academy of Engineering have actually done is looked at as the definition that's actually put there. They've actually tried to describe it as low impact and limited autonomous tasks. So they're talking about the impact, low impact, and what tasks are actually required. And they're giving you some examples in there. Things like warehouse drones. The other ones you've got driverless trains. High impact, the judicial system support as autonomy for selected tasks. And then high impact, mostly autonomous, talks about things like social care robots and things like that aspects to it. So that's how they've decided and categorized it. And I think within the maritime sector, I think what we need to do, not take the models that the IMO have actually done, but from a look at what the Royal Academy have done, and actually look also at what the US Defence Science Board has actually put forward. That would be my answer to that.
Yeah, I mean, I think I would take a slightly more practical approach to answering the question, and simply observe that cyber-enabled technology is that which is enabled through our ability to store and process data and information so rapidly and in such great volume. And this has come about, of course, because the technology now allows us to do so, and it is becoming ever cheaper. So we can now deal with mountains of data and have the systems in place to be able to undertake very comprehensive analytics through new techniques such as AI, machine learning and so on. So that is what I consider to be the enabler for cyber-enabled technology, the fact that this revolution is happening in being able to affordably manipulate vast amounts of data, store it and transmit it. And that's what's unlocking these capabilities. Would you agree?
Yeah, I would agree. I think one of the biggest challenges here is, do you actually have trust in the results of the analytics? Are you collecting the right data? What is the properties of the data itself that you're actually collecting? The great one is time. Time is a property of data. The interesting thing is that the time itself, for low pressure on an engine, that time is vitally important. We're probably talking about, I don't know, milliseconds. We need to understand whether the pressure is dropping or seconds. In a ballast water system, when I'm ballasting the vessel, the attribute of time is still the same. But you know, we may be talking here not seconds, but maybe tens of seconds, or even running into minutes. It's understanding that attribute is actually the correct attribute for the application in which we're actually using. So yeah, collect as much data as you like. My answer is make sure you're collecting the right data.
Absolutely. Thank you, Maria.
How do we ensure the comfort of those working on board? Would a remote operator be more likely to persist in bad weather despite the comfort of the crew?
You know, that's an excellent question. Me and Matt were actually talking about this. I've been at sea many times in Gale Force 10 and beyond, and you do bring the speed of the vessel back. The reason for that is it's very uncomfortable on the vessel itself and puts stresses on the vessel. But if I'm sitting in that remote control centre, do you want to flag a picture up of the remote control centre? There's one in there, Maria. You just go down. Right, if you find it. If I'm sitting in a really comfortable air-conditioned remote control centre, I'm not going to have that feedback, that tactile feedback of what's happening on the vessel itself. So I can actually be controlling the vessel without any consideration of the human that's actually on board. It's a really, really good question. You know, that one, for instance. Yeah, that one, right? So if I'm actually controlling that vessel, then you know, it's a very, very good question which has actually been raised and needs to be taken into consideration.
I think it's a great question, and you know, the thought experiment that we had at Engines as a Weapon this year around what would happen for a ship that's being controlled from one country, is flagged under another country, with a crew on board who perhaps unable to interact with machinery, but look out of the window and see an accident about to happen, another platform under distress. You know, what do you do, and who has the responsibility? And back to your point about liability and the legal implications. And also, I started thinking about one of your slides around naval engineers at sea and their role to operate, to maintain, or both. And in the Royal Navy, we've been through a period where we have seen our engineers more as operators than maintainers, to our perhaps peril in realising that actually we needed to restore some skills in some of our people to maintain, diagnose and repair, as well as operate machinery in order to sustain our platforms for long periods of time away from base port. If you then consider a naval platform that is perhaps being remotely operated and the ship's crew are not there to operate, they are now simply there to maintain, because the platforms are complex, because they are away from base port for long periods of time. What does that mean to them and their behaviour, and even the moral component here of those individuals not necessarily being engaged and involved in the operation of the platform, but still being potentially in a relatively high threat environment? It raises all sorts of human questions that we would need to address through our journey in autonomy.
There is another question that says, would all these reduce the life of the ship? Because he comments that he cannot imagine using 40-year-old technology to operate on a ship, no matter how often the software is updated. Do you agree with that statement?
There's certainly an issue here. You relayed a story to me, I think last week, Bernard, about the resale value of
Right.
the value of a ship and the market, and I think it brings that issue to mind.
Okay, so I was talking to some influential ship owners, and I was trying to explain the presentation, and we were talking about sort of what type of fuel you're going to burn. So what do you have to burn? Fully compliant fuel, or we're dealing with hybrid drives, etc., to increase the technologies. Then we talk about no single point event shall result in a key hazard. So okay, so that means my ship has to be designed to prevent a key hazard. In that case was fire and flood. So I'm increasing the level of complexity in the design. Am I now aiming towards more like the DP3 principles of separate systems? Then we looked at things like maintenance. How do I do the maintenance on board where there are no services required for habitability? Does that mean I have to have specialist teams, or do I have to stay in port longer? What's the dispensation if I do put people on board? If it is, then where do I do it, etc. So there's that aspect to it. And then we came down to the critical point. So far we were doing okay, all right? We were doing okay. And then we came down to the point to turn around and say, well, actually the requirement to operate and gain the certification may mean that you have to provide a justification how the safety argument has actually been met. And that has to be maintained throughout the life of the asset. And as soon as I turned around and said that, I got basically stopped. And the reason I got stopped was basically because the ship owner turned around and said that means that either I have to employ people who understand how to work within the safety case regime, which actually for naval people is a massive opportunity, I would suggest, all right, because they know how to do it. Or do I have to delegate that authority off to a third party for them to do it for me? And if I then try and if I in the resale market, if I want to sell my vessel, at the moment, when it goes up for sale, they can sell it. There's a large number of organisations and companies out there who will actually take that vessel. But if one of the criteria is I have to maintain the safety argument throughout the life of the asset, that's limiting the number of companies I can actually sell my vessel to. And it was that point in time that we stopped the argument and we sort of moved on. But these are some of the challenges that we're going to face. It's not only the technology, we have to think of it through life. You know, what does that actually mean for the ship owner in terms of the resale value of the vessel itself? Never mind the capex cost, you know, as we go through life. So it's a challenge, all right? But it's a risk, it's a challenge, it's a risk that needs to be identified and addressed and mitigated before people embark on this technology or adoption of the technology.
That leads me to the next question. Which risk analysis methodology is being used? Does this differ for risk and cyber risk? It's a question from another person.
Which risk?
Which risk methodology?
Oh.
Is there a specific one?
No. What's basically happened for the projects which have actually been put in the water at the moment, they've used hazard HAZOP, bow tie, and there's nobody specifying, none of the class societies actually specify a particular methodology, because it's left open during the debate. And it is a debate, it's not us and them anymore. It's a debate to turn around and say which methodology would be acceptable, that would give confidence to the regulatory authorities, would allow them to satisfy themselves the safety argument has been met. One of the things that have actually been used is a thing called goal structure notation, which is a graphical representation that demonstrates how the safety argument has actually been met. But the methodologies that are actually used and the for assessing the risk, no, that's been completely left open at the moment.
So I suppose what you're saying is that we don't necessarily need any new approach. The approaches that we currently have for managing risk, managing safety, can be applied in the cyber and digital age, so long as they are thought about early and applied properly. Then the tools that currently exist are sufficient.
Yeah.
Yeah.
I'll just add to that in a minute, because we're dealing with software-based solutions. What we we'll talk about the commercial world in a moment, and then we'll do the naval. So within the commercial world, there was a move to introduce the standard called IEC 61508 within marine, and that got rejected quite rapidly. The issue here is that as we're dealing with a software-based solution, we really need to understand and decompose it to a point is what is the integrity level we're actually designing to. Now, we've got two methodologies. You've got safety integrity level. If you go to DO178, for instance, you've got the design assurance level. And I think we need to start introducing a methodology, certainly for trying to understand what levels we actually need to achieve. So obviously we can't afford to build everything to a SIL 4 requirement. You know, that's no ship owner would actually do that. In terms of the design assurance levels out of DO178, we know that process in principle actually works exceptionally well. So could we take the extracts from DO178 without fully claiming compliance with DO178? We use the principles out of DO178 to turn around and say we're now going to design to a DAL level of whatever that assessment comes out. I think that's one of the big gaps that's missing within the industry, the commercial world at the moment. And I'd say to a certain extent, right, in the naval environment itself, you've got, you don't use 61508, although there is a naval version of 61508 that's come up. I don't know whether it's been released yet, but I'm still trying to find out. But we need to have that methodology in place, right? But in terms of the risk side of it, open.
Okay.
We have many questions, but we're running out of time. I'll take one more, if
Yes.
you don't mind. As far as you're aware, how has work on autonomous vessels to date dealt with functions which required onboard human judgment? For example, collision regulations and challenging pilotage. Are you aware of any issues and how they have been dealt?
Yeah, they've been dealt with very easily.
Good. That's good.
and I'll explain the reason why. Is that all the projects that have actually put forward so far is we've always had on the commercial world to demonstrate is we've always had a master on board the vessel, and the ultimate risk mitigation is the master is always in command. The master on the vessel is always in command. So in terms of the tug, the Svitzer tug demonstration, what happened in that case was that if the master on board the vessel felt that there was an unsafe condition, then all they did was press the big red button. And in fact, the classification society recommendation was make the button bigger. All right, so you didn't have to look for it too closely.
But it does introduce this idea of the human crumple zone, doesn't it?
Yes.
As you discussed in your presentation, which is an interesting phenomenon which we'll have to deal with.
Absolutely. But the interesting thing is, if I now take the master off the vessel, and I now only have people ashore, then there is some significant challenges ahead, because we don't have that fallback position of the master being in command on the vessel itself. So to date, touch wood, everything's worked okay. We haven't seen a situation where the master on the vessel has had to take command, take control back on board the vessel itself. But that's only during the demonstration phase, all right? So I'm going to keep my fingers crossed that we're going to proceed in exactly the same way. But it's a really valid question that's been put forward. Right?
Thank you, Bernard.
I've got one question I'm thinking of is, so we've talked about cyber security and autonomous. We have a level of autonomy on most of our naval vessels as they exist at the moment. And as you already highlighted, that the cyber security aspect is not well understood. What would be the key risks that Navy should be looking at for their current platforms that have levels of autonomy within their engine management systems, their platform management systems, navigation? What would be the key areas to focus on, to retrofit something to be not perhaps cyber worthy, but maybe more cyber secure? Okay,
it's a good question. Some of the biggest challenges you're going to face are patching, software upgrades. The people walking on board your platform with your pen drive, phones, anything, all right? So it's you could turn around and say, what would you do? There's a word that's put around as well, cyber hygiene. Make sure you have a process in place to be able to manage it. The biggest challenge you're going to have, so when you say remote autonomy, what do you mean by that?
Well, so we have platform management systems that are controlling every aspect of the system. So, and they will be having uplink and downlink back to home, not necessarily a remote operating center, but a remote monitoring platform, and uploading that data, which is then a vector for intrusion, or the fact that we, as you say, people put patches, we have equipment that we bring on board from an obsolescence perspective, which then provide another vector.
Okay, so you're linked to shore and to the vessel itself. It'll be very interesting to find out, for you anyway, is it just a one-way traffic? Is it from the vessel to a shore, or can I actually download information from a shore back to the actual technology itself, which is on board? I don't know the answer to your question. I would be very surprised if it's a two-way link.
Yeah, I think from a naval perspective, actually, it shouldn't be as difficult, because we're already in a place where we manage security very carefully, where we control probably better than most anything that goes on and off a platform, whether it be digital or otherwise. What's slightly different here, and perhaps is the challenge or the opportunity, is to recognise that there is an element of necessary security, cybersecurity awareness, a training requirement and a skills requirement. And when I think about the role of engineers in the naval environment, the ability to understand networks, how to protect networks, ought to become as common as understanding Ohm's law. It's just going to be one of those skill sets that all engineers in the naval environment will have to have. Okay.
Great.
So I think we ought to draw a line under things there. We've probably we've run slightly over time, but thank you all very much for joining us today. Thank you all for your engagement and your questions. On behalf of you all, on behalf of the IMarEST, and on behalf of the Naval Engineering Special Interest Group, a huge thank you to Mr Bernard Twomey for delivering such an informative and thought-provoking webinar that's generated much discussion. I feel this may just be the start of a series, Bernard, on this immensely topical subject. Don't forget, you can continue your discussions on the Naval Engineering SIG Nexus page, and for IMarEST members, remember you can sign up for free membership of the Naval Engineering SIG through the My IMarEST section of the website. Please look out for the forthcoming webinar programme that we also intend to publish on Nexus, and I very much hope that you'll be able to join us again. Thank you.